Yo, 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 it's Credias. How's everybody doing? Welcome to the video for solving two-step equations. Now, uh, this right here is a two-step equation. So what we're going to do is it's the same thing as solving a one-step equation, except for now we have to take more than one step to solve it. So that means we have to do multiple operations in order to get the variable by itself. So quick recap, the name of the game here, the goal is to isolate the variable. So we want to get our variable by itself. So I want to figure out how to get x all by itself. So I want to know what is x. Okay, so that's what we're solving for. We're trying to figure out 3 times what plus 15 equals 36. I need to figure out what that value for x is. Now we do this by using inverse operations. So I always do the opposite to cancel things out. So if I'm looking at this equation, 3x plus 15, what I'm trying to do is I need to figure out a way to get rid of this plus 15 here, and I need to figure out a way to get rid of this 3 times x right here. So I'm trying to get rid of the 3, and I'm trying to get rid of the plus 15. So this is where we use the opposite operations. Okay, so what I want to do is I am going to do step 1, and then I'm going to do step 2. So I'm going to do step 1 by canceling out the constant by using addition or subtraction. So I know order of operations has always said, hey, order of operations, PEMDAS, you do parentheses, exponents, multiplication, division, and then you do your addition and subtraction. Well, equation is a little bit different. We actually normally, almost always, I have an exception. There's an exception to that, a couple exceptions, but I'll show you one exception in this video. We almost always do our addition and subtraction first before we worry about doing our multiplication and division. Okay, so it's a little bit backwards from order of operations. So again, I got 3x plus 15. I want to get rid of this plus 15. So I need to ask myself, what is the opposite of plus 15? And the opposite is minus 15, because I want to get rid of this. I want to cancel it out. Okay, so what I'm going to do is I'm going to subtract 15 right below it. And it's really important to show our steps just like this. Because 15 minus 15 is 0. It goes away. That's the whole point of doing it. But whatever we do on one side of the equal sign, we have to do on the other side of the equal sign. That's why I like to draw this line to show, okay, cool, I subtracted 15 on the left side, so I need to subtract 15 on the right side. This keeps me in order, make sure I'm doing all of my same steps. I also need to bring down my 3x. So I didn't do anything with that yet, because I can't subtract 15 from 3x. That's why I was able to subtract 15 from this positive 15. So I have 3x equals 36 minus 15 is 21. Now if you guys look, we have a one-step equation from here. Okay, this is just 3 times something equals 21. Now, some of you mentally can do that in your head. It's 7, that's fine. But again, we always want to show the process for how do we get there. Okay, so I need to figure out what is the opposite of multiplication. So this is 3 times x, so the opposite of multiplication is division. So I'm going to cancel out this 3. I want to get rid of it so I have my variable by itself by dividing by 3. The reason why we did that, 3 divided by 3 is 1. They reduce to 1 and cancel out. Because it's 1, if I had 1x, there's no point in writing the 1 in front, because that really means that x is by itself. So that's why they're able to cancel, because they make 1. I also bring down my equal sign, and then now whatever I did on the left side, I have to do on the right side. So because I decided to divide by 3 on the left, I have to divide by 3 on the right to maintain balance of that equation. 21 divided by 3 is 7, and I'm done. So that was 2 steps. Our first step was to get rid of our addition and subtraction. Our second step was to either do our multiplication or our division. Okay, and that's it. They're all pretty similar. I'll show you one exception, but they're all pretty similar. So if you want to try this one already on your own, give it a shot. Pause the video. Try it. Like, there's no harm in doing that. Okay, so first I want to undo my addition and subtraction. Or I want to undo my constant by using addition and subtraction. So the constant's the number that doesn't have a variable attached. So right here, this 40 is my constant. This 40 is just being added or subtracted with this 3n here. Okay. Now the best way to look at this problem though is, I know this looks like 40 minus 3n, but let's just look at this as a positive 40 being combined with the negative 3n. Okay, because what we can do with this positive 40 right here, because this is positive, is I just want to get rid of it, because 40 is just being added or subtracted with this 3n. So because it's being added or subtracted, my goal is to get rid of the 40. So I need to ask myself, how do I cancel out 40? How do I just get rid of a positive 40 that's not being multiplied or divided? It's just kind of floating out there. We call that a constant. So goal, cancel out the 40. The way I do it is because it's a positive 40. I know if I subtract 40, because 40 minus 40 is 0. Now I can do this because this is not being multiplied or divided with anything. It's just out here being added or subtracted. So I can subtract 40 because 40 minus 40 is 0, and it goes away. I can also do it. I also have to do it on the right-hand side. Okay, so I bring down my variable. I have negative 3n. The negative's fine. It doesn't change anything about this. Bring down my equal sign. And then I have to do negative 23 minus 40. I have a negative and I'm subtracting, so I'm going further negative. Okay, so I have negative 63. Okay, so negative 3 times something equals negative 63. Okay, so now what I need to do is now I need to divide both sides by my coefficient right here. So because this is negative 3 times n, that means I need to divide by negative 3 to cancel it out. That's my goal, is to get rid of it. Okay, so I got to divide by negative 3. Whatever I do on the left side of the equal sign, I got to do on the right side of the equal sign. So I need to divide by negative 3. This division undoes this multiplication. It cancels it out. So I'm left with n equals negative divided by negative is positive. 63 divided by 3 is 21. Okay, so first we always get rid of that constant, the number that's not being multiplied or divided, by subtracting or adding. If this was a negative number, if that was a negative 40, I would have added 40 because negative 40 plus 40 equals 0. We're trying to cancel it out. Okay, and then after that, we would then get rid of our multiplication or our division by doing the opposite. And now I have my variable by itself. I'm good to go. This is why it's so important to make sure we do our work on top of one another, that we make sure we line everything up, and that we show our steps just so we don't get confused, especially when we have even more than 2 steps. Okay, so I got 2 problems on this next one. And this is one of those exceptions I was talking about first. So let's look at the one on the left-hand side first. So only focus on this one. Maybe try it on your own, see how you do. It's no different. I know we have a fraction here, but we all know fractions are division. So if I have a division problem, that means just my last step would be the opposite of division, so the opposite of multiplication. Okay. So my first step, get rid of this constant right here. Get rid of the addition and subtraction, the number that's kind of sitting away from the variable not being multiplied or divided. So I want to get rid of this positive 6, or this plus 6, by subtracting 6 on both sides. That's always the first thing. So we can almost always the first. I gotta stop saying always because we're gonna show an example of when that's not the first thing. These go away. Okay. Bring down my m divided by negative 3 equals 4 minus 6 is negative 2. So now so far we haven't done anything different from the other ones. So the only difference now is this isn't negative 3 times m. This is m divided by negative 3. So now we got to say, okay, cool. So this is division right here. So what is the opposite of division? And the opposite of division is multiplication. So what I need to do is I need to multiply both the left and the right by negative 3, because that's the number I'm trying to get rid of. Okay, we always do math with the number we're trying to get rid of. That's the number we're using to get rid of it. So, and the reasons why these cancel, if I kind of extend this out, this is 3 over 3, just like when we did our division earlier. Okay, this makes 1, goes away. Bring down my variable. I'm left with m equals positive 6. Negative times negative is positive. And again, one thing, I didn't mention this earlier, but I mentioned in my previous videos before, you can always plug in your answer into the original equation to see if it worked, which I highly recommend you do to make sure you didn't make any mistakes. So I can plug in 6 for m. So that means I have 6 divided by negative 3 plus 6, and that is supposed to equal 4. So I'm going to simplify this side and see if I get 4 for my answer. 6 divided by negative 3, that's negative 2. So I have negative 2 plus 6. Negative 2 plus 6, I have different signs, so I subtract, and that is equal to 4. So I'm good. I solved my equation correct. M does equal 6. Okay, if I plug in 6 for m in my equation, it works. If I go to a previous equation, I could do the same exact thing. I could plug in 21 for n here. 3 times 21 is 63. So I would have 40 minus 63, and that would give me negative 23. I would do the same thing on this one. 3 times 7, x is equal to 7. 3 times 7 is 21. Plus 15 is 36. It works out. Okay, so now this equation right here, this is one of those exceptions that I wanted to show you. So I said we always, pretty much almost always, want to get rid of the constant or the addition and subtraction first. But take a look at this one and see what looks different about it. Okay, so what looks different about this one is I have r plus 7, but all of that is being divided by 4. Okay, so it's not just the variable that's being divided by 4, it's the whole entire upper half. The plus 7 is also being divided. So because this positive 7, this r plus 7 is all being divided, because 4 is underneath all of this, okay, what I need to do is my goal is to get rid of this divided by 4 first, which is no big deal. So it's not crazy different, but I do need to get rid of this divided by 4 first. And you do it the same way you would have done it over here, the same way we do it any other time. Because this is divided by 4, the way I get rid of it is I multiply by 4, because this cancels each other out. And whenever I do on the left side the equal sign, I have to do on the right side the equal sign. It doesn't change anything. It just changes what we do first. So in this situation, this is where we want to get rid of this denominator first, because everything's being divided by it. Okay, I can't actually work with this 7 until I do this, get rid of this 4, because then I can get rid of it. Okay, because everything is being divided by 4, that means these 4's still cancel out. I don't have to actually multiply 7 by 4. I don't have to. I'm just canceling these out. That's what they do. They cross simplify. Like if this was 4 over 1, I want to cross simplify before I multiply it. This 4 and this 4 cancel each other out. Okay. I bring down what I have left. I still have this r plus 7 equals 5 times 4 is 20. Now I can subtract 7 from both sides, because that would give me 0 there, and I'm left with r equals 13. Okay, and again, we can check that. I can do 13 plus 7. So I replace my r equals 13, so I replace my r with 13 over 4. 13 plus 7, that is 20 over 4, which is 5. 20 divided by 4 is 5. Perfect, that's what I got. So it worked out. All right. Oh, I got a joke for you guys. Okay. What do you call two friends that are in math class together? So what do you call two friends who are in math class together? Algebros. Whew. It's one of my favorite ones. It's a good one. All right. Now, what I definitely want you guys to do is try this one on your own. Do not just wait for me to do it. Try it. Make sure you got this down, and then this will be the last problem of the video. So pause it if you haven't done so already. All right, cool. So now I got negative 4x plus 18 equals 62. So again, my goal, let's get rid of the number that's being added or subtracted first, just because there's nothing else happening to this 18. It's not being divided. It's not being multiplied by anything. So I want to get rid of this. So because it's a positive 18, I need to subtract 18. Okay, and I need to do it from both sides. Boom, 18 minus 18 is 0, goes away. I need to bring down my negative 4x. I need to bring down my equal sign. And 62 minus 18 is, let's see, let's work it out because I'm struggling with my mental math right now. 5, 12 minus 8 is 4, so we get 44. Perfect. So now I have negative 4 times something equals 44. Okay, so because I have a coefficient next to a variable right here attached, there's nothing in between, this is multiplication. So to undo multiplication, I need to do division, and because it's a negative 4, I'm going to divide by a negative 4 to make it 1 and go away. Whatever I do on the left, I got to do on the right, so I need to divide by negative 4. So I get x equals 44 divided by negative 4, positive divided by negative, always negative, and then 44 divided by 4 is 11. I could go back and plug it into my answer to check to make sure I get 62. Negative 4 times negative 11 is 44 plus 18. That does give me 62. Checks out. Okay, that's it, guys. Good luck. If you have any questions, please let me know. All right, Gradius out.